Alright, so we are starting a new unit, Unit 5, and this unit is all about solving systems of equations. This word system just means you have more than one equation. So when you have two equations of a line, their solution is the point where they cross. Okay, so there are three different methods you can use to solve systems of equations, and I'm going to go over the method of solving them by graphing. So this is like the way to like solve it visually. Like we'll graph the lines and actually see the point where they cross. Okay. Okay, so I guess I didn't read this, but when you solve a system, you're finding the values of x and y that make both the equations true at the same time. Right? So when you're graphing, you're finding the point where they cross. So I have two lines here in slope-intercept form. So if I graph them, start at 3, slope of -2. Right, put a couple points in, down 2/1. This line, I start at -2, and I have a slope of 3, up 1, 2, 3/1. So this point here, which I didn't even draw in my lines, but this point is where they cross, so that's the solution. So the answer to this system is just 1, 1. And this is an x and y. If I plug this in to my equations, you would see that they work out. So for example, if I plug in a 1 for y equals -2 times 1 plus 3, you get 1 equals -2 plus 3, 1 equals 1. That's a true statement. If I plug it in here, so in here, 1 equals 3 times 1 minus 2, 1 equals 1, right? So that's the only point, that's the only set of coordinates where when I plug them into my equations, both of them are true, okay? All right, now there's a couple weirdos that happen, so let me show you what's going on here. So let's graph these lines. So start at +4, slope of 2, up 2/1, down 2/1. You know, get a couple points there. You can make your line pretty accurate. Here we go. We'll start at -3, slope of 2. Graph my lines. All right, so what's happening here? Well, if you know your math terminology, you know these lines are parallel lines. Parallel lines never intersect, right? So if they don't ever cross, this is going to be no solution. Or you can just write it out, no solution. So anytime when my system has the same slope and they start at different places, they're going to be parallel lines, and this is going to be no solution, right? So I can know that, I can see that before I even graph it. I just want to show you what was happening. So that's the first weirdo that can happen. Let's look at the second weirdo. So I'm starting at +3. Slope is 1/2, up 1/2. 1/2. Okay, lovely line. Next line, also starting at 3. I have a slope of 3/6, up 1, 2, 3. Okay, so you'll notice this is actually the same exact line, right? 3/6 reduces to 1/2. So if I have the same line, that means that these lines are constantly touching, constantly overlapping, okay? It's like a middle school relationship, right? You're like, you just stop touching each other. So this is going to be infinitely many solutions, okay? Yeah, so it's like every point on this line is a solution. So there are tons of solutions, infinitely many, one could say. These are the only two weirdos that will happen. And again, you can notice them before even graphing them. If you just notice you have the same line, infinitely many solutions, or just the same slope, starting at different places is going to give you parallel lines, okay? All right, got a couple more examples. Okay, for number 4, here we go. So you'll notice these lines are in standard form. Now, when you're doing these problems, like there's different methods of solving a system, and when they're in standard form, it's actually better to use the system or the method of elimination to solve, but we can still graph these. So you can either solve for y, or you can plug your x, you find your x and y intercepts, whatever you prefer. But if we solve for y here, -2y equals -x plus 6 divide by -2, I get y equals 1/2 x minus 3. Watch your signs. Negative over negative cancels out. 6 divided by -2 is a -3. Let's go ahead and graph this line. Start at -3, slope of 1/2. So that's up 1 over 2. Okay. Alright, now let me take my other line. 2x plus 4y equals 4. I move my 2x over, so it's a negative. Then I divide everything by a positive 4. So I get y equals -2 over 4 is a -1/2 x plus 1. Alright, so I'm starting at a positive 1, and my slope is a -1/2, so down 1 over 2, down 1 over 2. Now you only have to graph your lines until they intersect, right? Once I find this point, I'm done. Now, this would not be a correct way of giving your answer on like a quiz or worksheet or whatever. You have to write the coordinates. So this is over 4 down 1. So 4 -1 is our answer. Okay? Now, it's always important to know the process by hand and how to do it, but I'm going to show you how to graph it in your calculator. So you should have your calculator at the ready, turned on, ready to go. It's a couple different steps, and if you already know how to graph a line, that will be helpful. Let me see if I can zoom in and make it clear. Okay, so I first am going to y equals. This is where you want to go anytime you're graphing something. Okay, now if any of these up here are highlighted, if they're dark, you can just go up, put your cursor over them, and hit enter. So when I did that, it highlighted it. So if I wanted to unhighlight it, I would just hit enter again. You don't want those black, okay? So I'm going to put my first line in y1. So that's 3. Your x is right here next to alpha. So 3x minus 4. And for my second line, I'm going to do a -3x plus 2. So just a few notes here. When you're doing a minus, make sure you hit the minus button. When you want a negative, hit the negative button. Okay, seems kind of obvious. Sorry, you can't even see it. This is, of course, the negative button. But if you would put like a minus instead of the negative here, it's going to give you an error and it won't graph it. So if we graph our lines, beautiful, there they are. Now, we want to know where they're intersecting, right? And you can't you can maybe guess what that point is, but you can't see for sure, but there's an easy way to find your answer, okay? So if you're not at this point yet, I would pause the video so you don't miss what's coming next. But all we have to do is, you see this trace button, we want to calculate where they intersect. So I'm going to hit second and then trace. Now, it should be obvious which one we're going to pick. Number 5, intersect. So hit number 5. Now, once you hit number 5, I'm going to hit enter 3 times. Okay, so it's like abracadabra. 1, 2, 3. Now, intersection is 1, -1. There's our answer. So I did all of that just in the calculator. Okay, so quick recap. You go to y equals, you type in your lines. Your x is right here next to alpha. And just watch your negatives, or your negatives versus your minuses. Once you graph your lines, you're going to second and then trace. Number 5, you want the intersection point, and then you just hit enter 3 times, and it will give you your answer. So that's it. Hope that all makes sense. Thanks for watching.